Ready for a real mind bender. Today, we're going deep, deep into the human brain.
The most complex structure.
That's right, the most complex structure in the known universe.
Absolutely.
We've got research on baby brains.
Baby brains.
The wild story of Phineas Gage.
Oh, yeah.
We're even looking ahead to the future.
The future of the mind.
Digital immortality.
Really fascinating stuff.
You ready to unlock some secrets?
Let's unlock them.
Okay, so get this. Research suggests that we're actually at peak brain power.
Peak brain power.
The day we're born.
It's true.
Yeah.
Newborns can tell the difference between way more sounds than adults can.
Really?
Which means, think about it, a huge, untapped potential right from the start.
Wow, so what's going on in those little baby brains that makes them such incredible, learning machines?
Neurons, neurons, neurons. Babies, they're born with this abundance, just tons of neural connections.
Tons.
Way more than they'll ever actually use. It's like the brain's way of being ready for anything, you know? A dense forest of connections just waiting to be shaped.
Okay, I'm picturing this forest.
By all the things a baby experiences.
Right.
So as we experience new things, those pathways, the ones that are used, they get stronger.
Like building a trail through the forest.
Exactly. And the ones that don't get used so much, they kind of fade away.
Interesting. So that's how we end up specializing.
That's how we become experts in, well, whatever it is we do.
Our brains basically start with this massive toolkit.
Massive toolkit, yeah.
And as we go through life, we figure out which tools,
The ones we need, yeah.
the essential ones.
And which ones we can toss aside. And speaking of, there was this fascinating study
Was there?
at the Institute for Learning and Brain Sciences at the University of Washington.
Okay, go on.
This was back in 2004. And they showed, really elegantly, how ready for language babies are right away.
Real.
Even before they can say, a single word, their brains are already wired to recognize the sounds, all the subtle sounds of human language.
Wow, that's amazing. So while we might think of babies as just, eating and sleeping.
And, well, yeah.
You know what I mean?
Yeah.
Their brains are actually hard at work.
Oh, absolutely. It just shows how crucial those early childhood experiences are.
So important for shaping how our brains develop.
For sure.
Speaking of incredible abilities, sometimes they pop up in the most unexpected ways. And the story of Phineas Gage back in 1848 is a great example.
Oh, yeah.
We're talking railroad worker, horrific accident.
Horrific.
A metal rod through the skull.
Brutal.
Sounds like something out of, a movie.
It's hard to believe it's real.
Right. But he survived.
And that's the really amazing part.
So tell me more about this.
Well, Phineas Gage's story, it's not just, a gruesome tale.
Mm-hmm.
It's a pivotal case study.
The pivotal case study.
It really shook up early neuroscience.
Yeah.
Because it demonstrated the brain's incredible plasticity.
Plasticity.
Its ability to adapt, to rewire itself.
So even after a traumatic brain injury.
Even after something like that.
The brain can actually, hit the reset button.
Kind of, yeah. It can reorganize, form new connections.
Wow. So before Gage, how did people think about the brain?
It was seen as this rigid organ, very compartmentalized.
Each part with its own little job.
Exactly. And then Gage comes along, and his survival throws all that out the window.
So Phineas Gage's accident, as awful as it was, really changed our understanding of the brain.
Oh, absolutely.
This idea of neuroplasticity, that the brain can change and adapt, it's incredibly hopeful.
Incredibly hopeful. It means we might be able to, influence our own brain structure.
Really? Just by, living our lives?
To some extent, yeah. Through what we do, the experiences we have.
That is mind-blowing thought. Our brains are capable of lifelong learning.
Lifelong learning.
And adaptation.
Adaptation. We're only just beginning to understand what it can really do. It really is remarkable how adaptable the brain is.
Makes you wonder what we could accomplish if we could really, tap into that power.
Right.
And speaking of extraordinary capabilities, let's talk about prodigies.
Okay.
Those individuals who display, exceptional talents at a young age. Often surpassing even, adult experts in their field.
Right. Like those cases you sent over, Tanisht and Tiara Abraham.
Exactly.
Brother and sister.
Yeah.
Each with these incredible abilities in such different areas.
It's amazing, right?
Tanisht, a scientific mind, joined Mensa at 4 years old.
4 years old.
Can you imagine? And Tiara, a gifted musician, playing in the American River College Orchestra at just 7.
Wow, just 7. It makes you wonder, were they just born with these gifts? Or is it something in their environment,
It's the age-old debate, isn't it? Nature versus nurture.
It really is. So what does science say? Is there anything different about the brains of prodigies?
Well, research is still ongoing, but some studies have shown that there might be structural differences
Oh, really?
in certain areas of the brain,
Like what?
particularly those associated with, say, working memory, spatial reasoning, and even the areas dedicated to their specific talent.
So there might be an actual physical basis for their abilities.
It's possible. For example, there was this one study on musicians.
Okay.
They often have a larger corpus callosum.
The what?
It's the bridge that connects the two hemispheres of the brain.
Oh, right. I've heard of that.
So it's fascinating stuff.
It really is. But what about those cases where, this kind of genius appears later in life, seemingly out of nowhere?
Oh, you mean like the case of Derek Amato?
Exactly. The guy becomes a musical genius practically overnight after a head injury.
It's a classic example of what's called acquired savant syndrome.
Acquired savant syndrome.
Yeah, it's this rare phenomenon
Rare.
where people suddenly develop these amazing skills.
Amazing skills, like what?
Often in things like art or music or math after some kind of brain injury or illness.
Like a hidden potential just waiting to be unlocked.
Oh, exactly. And here's the thing. These abilities, they often show up in areas where the person had little to no prior interest.
Get out.
No, really. Like Amato, he had zero formal musical training before his injury, and suddenly he's a piano virtuoso.
That's incredible. It really makes you wonder what else might be hidden in our own brain.
Right. Who knows what we're all truly capable of?
That's kind of a nice thought.
It is a nice thought, although, not all of the brain's secrets are so positive.
That's true. We also have some research on psychopathy.
Right. A much darker aspect of the human mind.
Lack of empathy, remorse, sometimes coupled with manipulative behavior, even criminal behavior.
And it reminds us that the same organ capable of such incredible things can also be, well, quite frightening.
Exactly. And one case that really highlights this is Ted Bundy.
Oh, yeah. One of the most notorious serial killers.
Charming, intelligent, but underneath a very dark mind.
Right. In Bundy's case, along with a lot of the research that's been done on the brains of psychopaths, it suggests some interesting things.
Like what?
Well, there seem to be potential differences in their brain structure and activity compared to, the average person.
For example?
Well, some studies have shown reduced activity in the amygdala.
The what now?
The amygdala, it's the part of the brain that processes emotions, particularly fear and empathy.
So maybe that's why they don't seem to feel those things the way others do.
Potentially, but it's important to remember that brain imaging alone can't diagnose someone as a psychopath.
Right, it's not that simple.
Not at all. And it definitely can't predict how someone's going to behave.
So it's more complex than just saying, oh, look, a psychopath brain.
Much more complex. It's this whole mix of genetics, environment, personal experiences.
And to really illustrate that point, we have the case of neuroscientist Jim Fallon.
Oh, Fallon, yes. His story is incredible.
Tell me more.
So Fallon is studying brain scans of psychopaths.
Right.
And he stumbles across this scan, a scan that shows the same low activity in the orbital cortex. That's a part of the brain linked to impulse control.
Okay.
And guess whose scan it was?
Don't tell me.
His own.
No way. He had the brain of a psychopath.
It's true, but here's the thing. He lived a perfectly normal life.
How is that possible?
Well, it shows that genes aren't everything.
Okay, so there's hope for us all.
Exactly. Fallon had this predisposition, maybe, but his upbringing, his environment, they all played a role in shaping who he became.
So nurture really matters.
It really does. It's this constant interplay between nature and nurture.
Our brains are truly fascinating and a little bit terrifying all at the same time. It's amazing, right? Our brains are not just these fixed things.
Yeah,
they can change throughout our entire lives.
That's what makes it so exciting. So much possibility.
Speaking of possibility, what if our minds can reach beyond, our physical bodies?
Now we're getting into some really interesting territory.
Right. We've got research on remote viewing.
Ah, yes, remote viewing.
Being able to perceive things, get information about faraway places, just using your mind.
Just using your mind.
It sounds like science fiction.
It does, doesn't it?
But, we've got accounts like Angela Thompson-Smith.
Right, Angela Thompson-Smith.
She says she's used remote viewing to help police solve crimes.
Incredible stories.
Even help find a missing person, Stephen Williams.
Really makes you think, huh?
It does. So is there any actual science to back this up, or is it all just, stories?
Well, that's the tricky part about studying remote viewing.
It's big.
It's really hard to design, a foolproof experiment.
I can see how that would be tough.
Right. How do you completely rule out other possibilities?
Like what?
Chance, for one.
Okay, yeah.
Or maybe subconscious cues, things like that.
Right. I see what you mean. But didn't, governments used to take this stuff seriously?
Oh, yeah, you're talking about the Cold War.
Right.
The U.S. and the Soviet Union, they poured tons of money into researching this stuff.
No way.
Yeah. They even had code names for it, like Project Stargate.
Project Stargate sounds like a movie.
Right. They wanted to know, could they use this for spying? Could they weaponize it?
Wow. So what did they find out?
Well, a lot of that stuff is still classified.
Of course.
So it's hard to say for sure. Some of the researchers, they say they saw some pretty amazing things.
Really?
Yeah, but there's still a lot of skepticism out there.
That's understandable. It is pretty far out there.
It is. But you know what else is far out there?
What?
Digital immortality.
Oh, okay. Yeah, we're really going for it now.
Right. What if we could upload our consciousness, into a computer?
Like in a computer simulation.
Yeah, essentially.
Forever.
Potential. And there are companies out there like Nectome who are actually working on this.
Get out it. Seriously. That's wild.
Right. It's like something straight out of science fiction, but it's becoming more and more real.
So if we could actually do that, upload our minds, what would that even mean? Would that digital copy, would that be us?
That's the big question, isn't it?
It is. Would it have our memories, our personalities, our emotions?
Right. And would it be self-aware? Would it feel emotions the way we do? These are questions we need to be thinking about now.
Yeah, before it's too late, right?
Exactly. Because technology, it's not slowing down.
Not at all. This is blowing my mind.
Mine too. We've gone from baby brains to psychopaths to digital immortality.
All in? Like an hour?
It just goes to show the human brain, it's full of surprises.
It really is. So to everyone listening, keep those amazing brains of yours engaged. Keep asking questions, and we'll be back soon with another deep dive into the mysteries of the mind.
Until next time.
See you later.